Section 3.4, Example 2. Sometimes when we solve exponential equations, it's not as easy as rewriting using the same base on both sides. There are times where we have to use logarithms, and here are 4 steps to follow. Step 1, you're going to isolate the exponential expression. Now step 2, you either take the common log on both sides if you're working with base 10, or the natural log on both sides if your base is anything other than 10. Now, here are some properties you can use when solving, and then you end up just solving the variable, step 4. So on example 2, we're first asked to solve 5 raised to the x power equals 134. Now I can't rewrite 134 in base 5, and this is not base 10, so I'm not going to use common logarithms. I'm going to use the natural log. Take the natural log of both sides first. The natural log of 5 to the x equals the natural log of 134. The left-hand side can be rewritten as x times the natural log of 5 equals the natural log of 134. And just like back in Algebra 1, it's all about isolating the x. To undo this multiplication, we use division. We divide both sides by the natural log of 5. So we say x equals the natural log of 134 over the natural log of 5. That's the exact answer, and if they indicate we're to approximate or estimate or round, that's about 3.04. Next, we're asked to solve 10 raised to the x power equals 8,000. Well, this is base 10, so I'm going to use common logarithms. So you take the log of both sides. Log of 10 raised to the x power equals the log of 8,000. Now, if you'll look back on our 4-step process we follow, one of the properties that you need to remember is the fact that log of 10 to the x is always going to equal x. So we're going to use that here. So the left-hand side just becomes x, and that equals the log of 8,000. Now that's the exact answer. If it's okay to round or approximate, we say x is about, and you can check this on your calculator, 3.90. Okay, on the last part of example 2, let's see, these are not base 10, so we're going to have to use natural log. Take the natural log of both sides. Natural log of 3 to the 2x minus 1 equals the natural log of 7 raised to the x plus 1. This can be rewritten as 2x minus 1 times the natural log of 3 equals x plus 1 times the natural log of 7. Then we want to use distributive property on both sides. 2x natural log of 3 minus the natural log of 3 equals x natural log of 7 plus natural log of 7. And no, that is not the solution set. That's just something that was left on the slide. Okay, remember your objective is to get the x isolated. So now we're going to take this x and get it moved to the other side, and this minus natural log of 3 will go to the right. So a shortcut to think of is when you move to the other side, your sign changes. So on the left, I'll have 2x natural log of 3 minus x natural log of 7 equals natural log of 3 plus natural log of 7. Next, we're going to factor, let's see, out the x on the left-hand side. So we'll have x times the quantity 2 times the natural log of 3 minus natural log of 7 equals natural log of 3 plus natural log of 7. Okay, we're getting close to the end. Remember, it's all about isolating the x. So I undo that multiplication with division. I end up with x equals natural log of 3 plus natural log of 7 over 2 times the natural log of 3 minus the natural log of 7. Now that's the exact answer, but of course you would need to use your calculator if you're asked to approximate or estimate or round. And that would be, if you use your calculator, about 12.11. Make sure you get that with your calculator.